All right. Hi, students. For this lesson, you need to find this page in your science notebook. If for some reason you don't have it or you're missing, please pause to make sure that you get all three of these sections drawn into your notebook so that you can follow along with this quick lesson on thermal energy. So we're going to go through on three sections because this is going to set you up for your cup building process for the next in-person lesson. So make sure you're following along. Press pause to write things down at certain points, and let's get started. All right. So like I said, we're going to dive into these ideas of thermal energy. We're going to do a phenomenon or a real world event, and then you're going to start writing down some ideas for your project or your hydro flask that you are going to make. So what I want you to do is I want you to take 30 seconds and write down what you think thermal energy is, what are some examples, where is it used. So go ahead and press pause on the video and record your thoughts for about 30 seconds and then press continue. All right, once you got some of those thoughts in that first part, we're going to add some stuff after we watch this quick video.
Heat energy. Everyone probably knows something about heat. We often use the word to describe something that feels hot when we touch it, or to describe a hot day. To fully understand what heat is, we first have to understand something about energy. Energy has to do with the movement of the particles that make up matter. If we were to look up close at the particles of something very cold, we would see them moving very slowly. If their movement is very slow, they have less energy than the particles that make up something that is hot. For example, particles of hot water in a pot would vibrate very quickly, so they would contain lots of energy. Heat is actually a form of energy that is being transferred from a substance at a higher temperature to another substance or substances at a lower temperature.
Okay, that part might have been kind of confusing. What they mean is that thermal energy transfers from hot to cold. So thermal energy always transfers from hot to cold.
Have you ever touched a hot pot that was on a stove? What happens when you touch it? It burns your hand because the heat energy is transferring from the hot pot to your hand. Your hand had a different temperature than the hot pot. Your hand was much cooler than the hot pot. Heat energy always travels from a hotter substance to the colder substance. In this case, it travels from the pot to your hand. Think about what happens to a mug of coffee when you pour hot coffee into it. The mug felt cool at first, but then felt hotter as you poured the hot coffee into it. The hot coffee transferred its heat energy to the mug, which was cooler. Heat is not the same as temperature. Have you ever used a thermometer to measure something's temperature? Temperature is a measure of the energy that matter contains, or how hot or cold it is. So, when you use a thermometer, you are measuring how fast or slow the particles in matter are moving.
We're going to end there, but something I want you guys to understand with temperature is it is a way that you can tell how much thermal energy is in there. but it is a measurement. It is not the actual thermal energy. It's just telling you how fast or how slow the molecules are moving. If you have a high temperature, it means you have more thermal energy because the particles are moving faster. If you have a low temperature, you have a lower thermal energy because the particles are moving slower. We're going to end that video because we're going to talk more about heat versus temperature next week. So I want you to go back and maybe take 30 seconds. What else would you add after watching that video to that first box? Go ahead and press pause, add those in, and then press play when you're ready to go. All right. So now we're going to move down to your second box where we've got the phenomenon. So this is like a real world or event or an investigation. Many of you have a insulated water bottle, like a hydro flask, a Yeti. There's something else that I can't remember the name of, but you get the idea. In that second box, I want you to brainstorm. Why do hydro flasks, Yetis, all these different thermal water bottles work better than just my plastic Nalgene here? Want you to take as much time as you need to try to write down an explanation for why that is. Think about real world experiences, think about maybe some of the stuff we've seen in class so far, and try to answer that question. So press pause when you've got your idea written down, press play, and we'll move on to the next part. Okay, so our little project in the lab, you guys are going to create a hydro flask that will keep hot water for as long as possible. So we will pour hot water in it. You will measure the temperature every minute to see how much it changes over the course of 10 minutes. You need to start thinking about how you are going to design your cup to make sure that it maintains its heat for as long as possible. If you go back to the assignment page, there will be a list of all the possible materials that you can use. Everyone is going to get roughly the same materials to start with, and your job is to try to create the best cup that you can with that. And I want you to start drawing out, start labeling where you want to put certain things on your cup, and that's the final thing you need to do for these notes. So nice job, everyone. Make sure you get a rough design of your cup, because we're going to give you about 25 to 30 minutes to build it in class the next time that we see you. So it's going to be a pretty quick build, but I think if you've got your ideas, you'll probably be able to get it done within, probably even before that 25, 30 minutes is done. So go ahead, start planning, guys, and we will see you next time.